This is Mr. Hassan's Maths channel. I'm now answering question number 8 from the October-November 2023 session of the Cambridge 9709 paper 3 variant 2, which is a pure mathematics 3 paper for the international A-level. And this question here is about complex numbers. And question A, we're told it is given that 2a plus 3ai over a plus 2i is equal to lambda times 2 minus I, where a and lambda are real constants. Show that 3a squared plus 4a minus 4 is equal to 0. Okay, so basically what we have to do is we have to take this and we have to change it in such a way that the denominator is a real number, which is called realizing the denominator. And it should give us something of this form. So how do you change something such that the denominator is a real number? Well, you multiply it by what's called its conjugate. You multiply it by its conjugate, which is the thing which when you multiply it by it will get rid of the complex number part of it. You have the imaginary number part of it. So I is an imaginary number. Its value is -1. I squared therefore is equal to -1. So we want to get rid of this part. So we multiply it by its conjugate, which is the thing which you multiply it by it, and it will get rid of the imaginary number part. It's kind of like rationalizing the denominator in terms of the same principle. You multiply it by something which gets rid of that part that you don't want, and that is basically based upon the difference of squares. So if I multiply this denominator by a minus 2i, then when you expand it, the middle term will disappear. So you have a plus 2i. If I multiply that by a minus 2i, which is the same numbers but the opposite sign between them, if I expand this, you're going to get a squared, and you're going to get minus 4i squared. And the I squared will be -1, there'll be no I. The middle term, which will be minus 2ai plus 2ai, will become, it will be cancelled out basically. So, but if I change the denominator, the numerator must also be changed. So if I multiply the denominator by a minus 2i, the numerator must also be multiplied by a plus 2i. Let's just put that correct. That's 2 plus 3ai, also multiplied by a minus 2i. Okay, so that will rationalize the denominator and it will give us something in the form lambda times 2 minus i. Okay, so if I expand the numerator, I have 2 times a, which is 2a. Where did my pen go? Hold on. Missing. So I have 2 times a, which is 2a. I'll put it down here, 2a. And 2 times minus 2i, which is minus 4i. And 3ai times a, which is 3a squared I. And 3ai times minus 2i, so plus times minus is minus. 3 times 2 is 6, so you have 6a times I squared. And the denominator of this is going to become basically just a squared minus 4i squared, because the middle term, which is minus 2ai plus 2ai, will be gone. And that's what we want, because this will become -1 and we will have no I term in the denominator. And that should give us something of the form lambda times 2 minus I. Okay, so now let's continue and simplify this. So this will be 2a, and you're going to have, this is going to become minus 6a times I squared now. Minus 6a times I, keeps changing, what's going on here? Okay, so minus 6a times I squared is the same as minus 6a times -1, which is plus 6a. So this is going to become positive 6a, so I'll put it here with this, so I can combine them. And here I've got, let's write it in this way, 3a squared minus 4, and all of that is the I term. So I've just got the the real part here and the imaginary part there. Okay, and that's divided by of a squared minus 4i squared. Now remember, 4i squared is 4 times -1, gives you -4, so it's going to be a squared plus 4. That'll be a squared plus 4, and that's all equal to lambda times 2 minus I. Lambda times 2 minus I. Okay, so now, basically what we can do here is we can split this up into 2 parts. We can say this is like 2 times, so this is going to be 8a over a squared plus 4. And this is going to be plus 3a squared minus 4 over a squared plus 4i is equal to 2 lambda minus lambda I. Okay, so the way I would continue from here is I would basically compare the coefficients of lambda of I and the real and the imaginary parts, because this is the same as that. If this is the same as that, then the real parts must be the same as each other, and the imaginary parts must be the same as each other. So the real parts are basically this and this. So what we can say here is that 8a over a squared plus 4 is the same as 2 lambda. And from the imaginary parts, we can say basically that this is the same as this. Okay, so what we can say from the imaginary parts is 3a squared minus 4 over a squared plus 4 is the same as minus lambda. Okay, so I can divide I can divide this by 2. If I divide by 2, this will be 4a over a squared plus 4 equals lambda. So I've just divided by 2. Okay, so if I divide this side by 2 and that side by 2, the 2 will cancel, it will become 4 then. And here I can just write this as 4 minus 3a squared over a squared plus 4 equals lambda. Because that's minus lambda, I can call it lambda. So now, if these two are both lambda, they must both be equal to each other, because lambda must be the same. Which means that 4a over a squared plus 4 must be the same thing as 4 minus 3a squared over a squared plus 4. If I multiply both sides by a squared plus 4, they cancel out, and we're left with 4a equals 4 minus 3a squared. And I want to show it with the 3a squared positive, so I can add 3a squared to both sides. So I have 3a squared plus 4a, subtract 4 from both sides, minus 4 equals 0. And that's exactly what we had to show. Okay, that's what we had to show. Show that 3a squared plus 4a minus 4 equals 0. 3a squared plus 4a minus 4 equals 0. So we've got exactly what we had to show. So there's part A of the question. Now we're going to solve part B. Okay, so we might need some of these bits of information here. So I'm going to just basically take this with us in case I need it. Okay, so we had to show this, and we need this information here. Okay, so we've got different values, different expressions for lambda involving a, and we've got to find the possible values of a and the corresponding values of lambda. So basically I have to solve the equation 3a squared plus 4a minus 4 equals 0, and find the values of a and therefore the values of lambda which satisfy this equation. So now, to solve this, I'm going to try to factorize it. So I've got, let's see if we can factorize this. I think we should be able to. From the numbers, it looks kind of like it can be. So I've got 3a squared and negative 4. The product of those two is negative 12a squared. I need to find two numbers. When you multiply them together, you get negative 12a squared. When you add them, you get plus 4a. Okay, so those two numbers, 6 and 2 would work, isn't it? So it's going to be positive 6a and negative 2a. Those two numbers multiply to the same as these two, and when you add them, you get the middle term. So we know that that's correct. So now we can factorize. So In these two terms, the common factor is 3 and a. Now from this, we can just say 3a times a is 3a squared, 3a times plus 2 is 6a, and a times something is minus 2a, that's minus 2. So now we have 3a minus 2 times a plus 2 equals 0. So let's see if that's actually correct. 3a squared plus 6a minus 2a and minus 4, that's correct. So a is equal to 2 over 3, or a is equal to negative 2. So those are two values of a, and now I need to find the corresponding values of lambda. So I have these two expressions here for lambda. So it looks like this is the easier one to use. You want to make life easy for yourself. So let's use the one that's got, less hassle, I think, to use. It's this one. So I'm going to use this one, although if I use the other one, I should get exactly the same answer. Okay, so let's start off with a equals negative 2. That's a bit simpler. So when a equals negative 2, lambda is equal to 4 times a. So it's 4 times negative 2 over negative 2 squared plus 4. That gives you 4 times negative 2 is negative 8 over negative 2 squared is 4. 4 plus 4 is 8. So that gives you negative 1. All right, so that's one pair of values. When a is negative 2, lambda is equal to negative 1. So that's one pair. And we have another pair when a is equal to 2/3. Lambda is equal to 4 times 2/3 over minus 2/3, not minus, it's positive. Over 2/3 squared plus 4. 2/3 squared plus 4. Okay, so that's going to give me 8 over 3 divided by, that's 4 over 9 plus 4. So 4 over 9 plus, let's get ready to add these together. So 4 over 1 is like 36 over 9. So I've just expressed the 4 as 36 over 9. Why? Because I want to add these together. So I have 8 over 3 divided by 40 over 9. Okay, so we know how to simplify that. So that's going to be 8 over 3 times, if you divide, you have to change the second fraction, the one after the division sign, to its reciprocal, so it's times 9 over 40. So we have 4 and 8 and 40, 8 goes into 45 times, 3 and 9, you got 3 goes into 9 3 times, you're left with 3/5. Okay, so we have our pairs of values. We know that when a equals negative 2, lambda is equal to negative 1, and when a is equal to 2/3, then lambda is equal to 3 over 5. Okay, it doesn't mention that a and lambda have to be positive or negative or anything, it just says they're constants. Okay, they are, if it says, in the beginning of the question, it says a and lambda are real constants. As long as they're real numbers, it doesn't matter if they're fractions, negative, positive, it doesn't matter, as long as they're real numbers. So that's the answer to question, was it 8, part B. Okay, so that completes this question, I think. Is there a part C to this question? I don't see it on this side. Is it on the next page? No, that's the next question. Okay, so that completes this question number 8. Other questions from this particular paper you can find in the playlist. Will be linked at the top of the screen at the end of the video. Other questions from the topic of complex numbers you can find in the playlist at the bottom right of the screen at the end of the video. You can subscribe to my channel by clicking on this link, and the video linked above will give you an idea of how to use my channel to find what you're looking for. Thank you for watching and see you soon.